Hello, good morning, everyone. Am I audible?
Good morning, Amol sir. We'll start. We'll start in 2 minutes.
Okay.
So, am I audible?
Yes.
Thank you, sir. As it is well said by Carl Pearson that statistics is the grammar of science. Good morning, everyone. Honorable Chief Guest, Mr. Amol Jadhav, respective coordinators, and all the staff members of PTVA, fellow teachers and students of different colleges. Myself, Pooja Sajwan, the host for the day, welcome you all for this super exciting webinar, Statistical Analysis Using Python, on behalf of Computer Science Department, Mulund College of Commerce. I would like to appreciate interest of all the participants in exploring more about statistics because the subject in itself is about analyzing patterns in data and drawing meaningful conclusions through it. And when it comes to predictions for future and questions like what will happen next, we all get very curious to explore. And the extraordinary combination of Python and statistics makes data analysis much more simpler and also increases our thirst to know more. I once again welcome each and everyone present over here and wish you all a great webinar ahead. Thank you. I would like to call upon my co-host Vamshi Budhana to continue this further webinar. Thank you.
I am audible. Hello.
Yes, we can hear you.
Yes, Vamshi.
Okay. Thank you, Pooja. Good morning, everyone. It's a great pleasure for me to introduce our expert speaker for today's webinar, Mr. Amol Jadhav, who is going to discuss investigation analysis using statistics from Kolhapur. Later on, he completed advanced program in fintech and financial blockchain at IIM Kolkata. Sir is an experienced data scientist, trainer, and a manager with over 14 years of work experience in developing AI ML modules and driving analytical projects. His key skills include deep learning, machine learning, and statistical modeling. Hands-on with the Python, Keras, TensorFlow, SAS, SSHPA, Tabula, SQL, PJSQL, R, Site Catalyst, etc. Currently, Sir is working as a senior manager in Fidelity Investment, managing a team focused in the healthcare domain. Sir has recognized multiple times in Fidelity and previous organizations for making significant contribution and business impact. He has received President Awards, Delivery Excellence, and Business Excellence Award by Fidelity for his outstanding performance. He has received first runner-up prize in national level project competition organized by Indian Society of Probability and Statistics, that is ISPS. He ranked first in the university in MSc Statistics. It's an honor and privilege for us, sir, to have you with us for the webinar on the statistical analysis using Python. I'm sure we will be enriched by today's session. Now I request Pooja to continue further.
I would also like to announce that we will be having a Q&A session, that is a question and answer session, after a respected guest of the day completes with his valuable teaching and guidance. So be patient and wait for your turn. Now I would request our guest speaker of the day, Mr. Amol Jadhav, to start with today's webinar. Thank you.
Yeah, thank you. Thanks for the warm welcome. I hope everyone is doing great. So let's get started. I will start sharing my screen. Feel free to stop me anytime if you have any questions or maybe anything that is not clear, or if you face any challenges and you would like to discuss as well. Let me share I'll begin by sharing my screen. Hope you can see my screen.
Yes, sir.
Okay. Yeah, so like Pooja mentioned, right, statistics is the grammar of science. It has many applications in a variety of industries, various industries, in the field of data analytics, data science. And data science is a new field which is taken over the world in the last couple of years, I would say, has been gaining popularity, and it's been used into various areas for various solving business problems. Right. Our today's focus is actually not on the data science, but to start with, how can we do some basic data analytics and data exploration using Python, and how can we do some of the basic statistical hypothesis testings, and then maybe start with a little bit of modeling using Python. Python is one of the widely used language in data science, so I'm sure you all know that, and we can if those who are not, you can get familiar themselves with Python. So what we can do is we can start with, I have shared the data set and notebook with you guys. So if you are able to load the notebook, we can start running it alongside me, and you can see how the outputs are coming, and we can discuss about the codes and outputs as well. If you are not able to, that's fine as well. I'll be explaining the codes and the output as we go along, and you can feel free and stop me if you have any questions. So I have the Jupyter notebook open. So what I'm doing is, firstly, I'm just loading some of the libraries. I'm sure you are familiar with some of these things, how to load libraries, how to import different libraries and load into the session. So this is a stats model library. We will need it for some of the hypertesting testing. NumPy, which is the numerical Python library. I'm just aliasing it with the name NumPy. And Pandas is another data manipulation library. And Matplotlib is the library that is used for visualization or plotting charts. And this Matplotlib inline magic function allows us to print the graphs within the notebook. And so I'm just running it. So it will just load the libraries into the session. After that, I have given a link here and also shared the data set. I chose a simple data set that you all can understand. So this data set is again from the Kaggle. It's an open source. You can find it from Kaggle website, and you can download it and play with. So there are variety of data set, many of different domains, business domain you can find on Kaggle. Kaggle is a data scientist competition platform. It is owned by Google now. But you can participate, you can into this competition, and you can win prizes as well. And you can also go to Kaggle to learn more about how different people are approaching the same problem from different methods, different approaches, and they're submitting their solutions. And you can also see some of those people who have solved this problem and have ranked in the top. Right? So what I'm doing is there is a function read underscore CSV. Since the file is in the CSV format, you can just load it with read underscore CSV and run it. And this will read the data set in your Python session, current session. So right, first thing what you want to know is whether my data is read properly or not, right? So you can just there's a df. I'm just loading the data frame into a data frame called df, and then I'm running a head command which will show me the top 5 rows of the data frame, right? So it is just displaying me some of the rows here, so that what we have is, gender, race or ethnicity, parental level of education, lunch, test preparation course, math score, reading course score, and writing score. So these are the different columns that we have, and you can see some of the values out here as well. So this is a quick way to check whether data is loaded or not. And then you can also do a df info, which will basically give you what are the different columns, what are these data types, right? Because what you want to know when you are reading or you are dealing with data set, you want to know what different type of variables do I have in my data set, right? Are those all categorical? Are those all numerical? How many values are there, right? So we see here there are like 1,000 records here in each of the columns. So here also you can get a sense of if there are any missing values in your data, whether my data types are like numerical, which is denoted by int 64. This is the data type, integer 64. These are some character or string variables which are stored as objects here. And from here you can get a quick info about, there are like 1,000 records, 8 columns, and so forth, right? Then you want to go, there's a df.describe function in Python or in pandas library.
Hello, sir. Sir, I guess your screen is freezed.
Wait, sir, it's not there anything.
Okay, okay. I request all the participants to wait for a few minutes till sir joins the meeting.
Sorry guys, I think my net connection was just, let's get back. Am I audible now?
Yes, sir.
Okay, yeah, thanks. Yeah, so after that, let's say you want to plot some of the charts, right? So what we can do for that, like there are different kinds of charts. So we'll just begin with plotting the distribution. So I'm just showing an example of one variable here. So math score. So before that, let's go back and see what the data set is, right? So we have a data set where there are scores of different students. So this is a students performance data set. We have scores in 3 different categories. One is mathematical score or maths ability. Then there is a reading and writing score, and then there is some test that was done, right? And the scores are recorded, and there's a variable that tells us whether this candidate or student has actually done the preparation or not, right? It's completed versus not. And a lunch, something we do not have a very good explanation about this, but there's some standard versus free lunch. And then there is a parents level of education. So what kind of education level the candidates parents have, either it's a bachelor, some masters, or basic level. Gender, and then ethnicity. So we do not have this explanation for gender, ethnicity, race. There are some groups here, right? So and on these lines we will do some plots and hypothesis. So first is we want to see, let's say, the distribution of mathematical or math score, right? So you can just plot. So this is a way you can select a variable from the data set, right? So you want to just plot for one variable, the histogram. So I'm just referencing the data frame, and then in bracket I'm just referencing the variable name in quotes, and then dot plot command, and then histogram. So when I plot this, I get a nice graph here, which is giving me a distribution of the score, right? And from here you can see how the distribution of score has been, right? So there are very few people who have, let's say, score between 0 and 20. Some people who have between 20 and 40. Majority lies around somewhere around 60 plus or 70, and then 80 range, and then a few people between 80 to 100, right? That's how the distribution looks like. I mean, you could just change the variable name, and then you can see how the distribution is for other type of numerical fields. And you can see here how the score has, or the distribution has changed for reading score, right? So with very simple changes, you can just explore and plot histograms or other charts for your other variables too. So this is one example of how you can see how the data is, the variable is distributed, whether it's symmetrical, skewed, positively skewed, negatively skewed, and so forth. Then you can look at, let's say, the next chart is the bar chart, right? So bar chart is again a lot of times used to infer about a categorical variable or a string variable, and you want to know the counts. Basically what you can do is there is plot counts. So what I'm doing here is, again, Python allows you to join or combine multiple different functions together in one line. So I have done here is, one is I'm just taking the race or ethnicity variable from the data set. Then I'm doing count on that, right? I'm seeing how many different categories are there within that variable and what are its corresponding counts. On top of that, I'm doing a plot. So I don't want to just get the counts, but I want to see in a chart, right? In the chart, and see what kind of distribution is there. And I'm specifying bar chart here. And with EH, I'm specifying it is a horizontal chart. And then you can annotate your charts with different colors, right? I want to have different colors for each of the bar. So I'm just giving the colors here, right? And once you execute that, you can see here a nice bar chart showing up here for each of the groups, right? Ethnicity has A, B, C, D, E groups, and it is accordingly already arranged in ascending order. So if you just change this bar, remove edge, and if you plot it, you'll get a nice the horizontal or vertical bar charts here that we usually plot. And you can see how the distribution or the counts are across different ranges. So you can see the proportion of values for each of this category in your data. And you can see here C has probably the largest number of records in our data. So we have about 1,000 records, of which close to 350 are corresponding to group C. And then 250 plus are for group D, and so forth. Let's dive further, and what you can do after that is we want to create some variables, right? So these are the two types of chart, but I'm going to create another variable. So I'm defining a new variable called average score. So I'm just giving the name of the variable and adding into the same data frame here. So in bracket you can reference that. And what I'm doing is I'm taking the sum of these three variables. So basically I'm taking an average because I want to take the average score our students have got across three variables. And here I'm just taking sum and then dividing by 3 because there are 3 variables. And then I'm rounding that to 2 decimals only, so that I have only 2 records. I mean the values are rounded to 2 decimals. So that's one variable that I'm creating, and then I'm creating another variable. I'm creating another variable which is called result. So you might have heard about Lambda function. So Lambda is another function that Python allows you to apply. So it allows you to create or apply some transformation onto the variable or a data frame without having to create a new function or without having to explicitly code another function here. So it allows you to write custom function within one line of code, and you can apply it on a data frame, and you can create a new variable or do some transformation. So the syntax is you apply lambda, start with lambda, then define a variable x, y, z, whatever it is, and after that you apply the conditions here, right? So what I'm doing is I'm saying lambda x. So x is the value of my variable on which I'm applying. So x is equal to f, that means fail if the score, right, for this data frame or this variable math score is less than 40, or it is less than 40 for reading score, or it is less than 40 for writing score. So if the student has achieved less than 40 score in any of the one of the abilities here, then we are saying that the student is failed, and we are creating that value as storing the value into a new field called result with the letter f, else it is 1, it is p, right? And there's also last argument here is axis equal to 1. So since I'm applying it onto the data frame, I'm putting an axis equal to 1. It means that just go and apply the operation on all the rows. If you, by default, the argument is 0, that means it will go on columns. So I'm specifying it so that it applies the argument on all of the rows and it creates the variable, right? So let's create that variable. So let's run it, and then you can see we can see the data frame here, how the new data frame looks like. It has added two records, two variables here, and you can see here average score and result being added here. And if anybody who has less than 40 would show up as fail. Right now, all three columns here have values greater than 40, so we cannot see that. But we want to definitely see whether how many records are having value f versus how many have p. So we can use the count values function. So on this variable, right, and there's another way, right? So one can use this method where you apply df, and then in square bracket you can mention the variable name in quotes, or you can just mention by dot, and then still will refer to the same variable that you're giving. However, the caveat is that if you have a space here, it may not work because Python would not recognize and it will throw a syntax error. So you want to use a square bracket with quotations if you are referring to variables which has space like this, right? Math score. So you can just run the value counts function, and you can see the values of p and f here, right? So we have about 494 students who have passed and 51 students who have failed. So I'll just take a pause here to see if anybody has any questions or anything that you want to ask before we proceed further. Any questions? All right, or you can also use the chat facility if you wish to post any questions there as well. Is the space okay? Or am I going too fast, too slow? Please help me understand so that I can adjust accordingly. All right, so let's keep moving. So the next category is box plot, right? Box plots are very helpful and in understanding a variety of things, especially about the data, right? How the distribution of that particular field is and so forth. So the box plot, so you have a df.boxplot command in Python where you can just specify the variable on which you want to do box plot, and you can also give a by category so that you can compare across different categories, different box plot. And this is just an argument that specify the size of the figure or the chart on the notebook. So if you just execute that command, it will show you some nice box plots here, right? So you can see here it has sorted the plots as per the alphabetical order of the by variable or the string variable, and then it has plotted the box plot. So what you can infer from box plot is basically you have the box here, which is at the center. The line separating here is the median. So you can see, for example, average or the median score for associate degree is around 65 or close to 70. You can say that, which is almost similar for many categories. For the master students, students whose parents are masters, their scores are slightly above, close to maybe more than 70. But those with high school is slightly below 70 as well. You can see that, right? And these upper and lower boundaries here is referred to the Q3 and Q1, so quartile 1 and quartile 3, and the lines are extended towards 1.5 times the interquartile end, which is Q3 minus Q1. So any points which are shown here like circles, usually those are called as outliers. For example, somebody has a score of 0 here for some high school, right? Possibly it is a data entry for the student may not have appeared as well, or maybe he didn't give the test as well because there is score 0 or whatever the other reason could be, right? So these points are referred as outliers, which are like way beyond the box and the range. And a box plot is a good tool to identify whether your data has some outliers or not. And as you will study more, you will see how outliers impact your data and the inference that you draw. Especially it affects regression lines considerably. So you want to know and identify whether your data has any outliers, and then you can treat them appropriately as per the need. So another widely used chart is basically you want to know the relationship between two variables. So for that, we use the scatter plot. And scatter plot help us plot the two variables on x and y axis, and you can get a sense visually how the two variables are related, whether there is any kind of relationship, linear relationship that you can see there. It could be in ascending or descending order or anything. So you can just use scatter plot. So the command is again df.plot dot scatter, and you can specify the values of x and y. And of course, there are many other annotations available. I'm just not mentioning that right now. You can use those to beautify your charts, right? So once you execute that, you can see there is a clear pattern that you can see the increasing trend. So as the math score is going up, you can see the writing score is also going up. So visually, you can see that there must be some significant correlation between these two variables. And this way visually you can plot the data, and you can see whether there are two or other variables are associated or not. You can do it for multiple variables and plot them, right? So this is a scattered plot. The next is what you can do is you want to a lot of times draw pie charts. So these are the different type of charts we typically use in our analysis. So I'm just showing you an example of one each. And you can of course play with it notebook with 5 different variables and see how the views change. So for pie chart, we need to know the proportion of variables, right? In the proportion of values for each of the pie. So you need to first identify the groups, right? So there is a group by command. So for the variable with race, we can use the df.group by command, which will basically group those variables, and then it will take the sum of the value that I'm giving you. So I'm giving the average score here. So it's going to take the sum of the average score across different race or ethnicity groups. And then it is going to plot me a pie chart. So kind equal to pi. And then it will get the proportions there. So it will divide that into, let's say, 100 percent, and then it will get the proportions accordingly for each category, and it will plot, right? This auto percent will basically plot the values on the pie chart. If you remove that, you will see only a pie chart without the labels, without the values, right? So you just see, let's say group D has 27, and then percent average score, and then the green is basically C, that has again the highest number of records, has around 32, and so forth. So this way you can plot your data in a pie chart form, and you can see how the distribution is. Again, this variable is not the right one to use for this analysis, but you can you can try. Let's say if there was a sales variable, you want to see the proportion of sales coming from each region, so forth. For those kind of things, you may want to use pie chart, right? That's one chart type of chart that we will be using often. Then sometimes you want to, let's say, compare two different uh, you know categories, how their scores are. So you maybe want to do a bar chart, which we have already done here, but this is another way you can just do the charts together. And what I'm trying to show here is, I mean, using a different way you can also, now there are, earlier what we have seen is we have plotted one variable and the values of those variables across the different categories. Here I'm showing how you can just plot three variables together and then compare the averages, right? So you can just calculate, so define the variables in a list, right? So y is, I'm just defining a list with three variables: math, reading, and writing. These are the labels, of course, and then I'm storing the means values in a list called means, and calculating the df mean for mean score, math score, reading score, and writing score. And I'm just storing that into a variable called list. And then I'm just using some pandas functions to plot that, right? So here I'm just plotting those in a horizontal bar chart where y is the label values, and I'm just taking the width of those as the mean values here, and it will just plot me. These are the some label and annotations. And of course, I also want to show the values here. So I'm just using the for loop here, which will go over the values of the mean list, and it will just plot the text here, plot.text, with two decimals, where I'm using the string function to round those values, and then in a black color and the center allocation and things like that. So this way you can just compare averages across different variables together in a visual form. Of course, you can do calculate it and then with manually in Excel or other software as well. But this way you can just
I guess some network issue from sir's side. Guys, please wait. Sir will join. Sir will join back.
I request all the participants to be in the meeting till sir joins.
Good morning, students. There is some network issue from sir's end. Amol sir will join back within 4 minutes. Till that, please wait. And again, we have already listened some things about Python using data analysis using Python, and I guess SY, TY students are there. They can correlate these things. We have already discussed these basic statistics in our syllabus. Yes, we have already discussed these things, how to draw or how to plot the graphs. We have already seen manually. And in TY, you will learn all these things using in computer science. We have data science. There we will learn all these things using R. But yes, when you enter into the market, you should be capable of doing the analysis using all types of tools. Yes, we have already done these things. We already know from histogram how to comment about the data. Now just we are learning how to do all these things using Python. So I guess you all are enjoying. Sir will join back in 2 minutes. Some network issue from his end. We have already again SY and TY students, we already learned these things. If you draw a histogram while looking towards the histogram, how to comment about its skewness. Sir showed that part at the starting. We already discussed the correlation also in first semester using the by looking towards the scatter plot, how to comment about the correlation. This also we have discussed. So just correlate with our theoretical part of statistics and Python. The role of data scientist is that only to use the data, use the technical tools, and comment about the result. Yes.
Yes, ma'am. And ma'am, it's quite relatable too because we have seen scatter diagram in FY, so we know very well how have you taught it, and that's why we can relate it very easily.
Yes, Pooja.
Good afternoon, everyone. There is a technical glitch on Sir's end, which will take some time to resolve. We plan to reschedule the webinar and the details of which will be shared on the group. Sorry for the inconvenience. You may all leave, and thank you for joining.
Thank you, ma'am.
Yes, you all may leave.